Let's talk about body plethysmography. Body plethysmography is a method for measuring lung volumes. The volume of lung that is usually measured with body plethysmography is the functional residual capacity. The functional residual capacity is the volume of lung that is usually measured with body plethysmography because it is the volume where the forces of lung recoil are equal to the outward pull of the chest wall. So as a result, at the functional residual capacity, the lung volume is not dependent upon muscles. So it is not dependent upon the muscles of inspiration or expiration, and it is a resting volume of the lung in a more reliable lung volume to measure. To measure functional residual capacity with body plethysmography requires the use of Boyle's law. Boyle's law is a pressure-volume law that applies to a closed system. And Boyle's law states that in a closed system, pressure and volume are inversely related. So pressure times volume equals a constant, K. As a result, in this closed system, what you can do is you can raise volume, and if you raise volume, you lower pressure. If you raise pressure, you lower volume. The two are inversely related. So the pressure times volume remains constant within this closed system. As a result, the pressure 1 times the volume 1 in a preset status will equal the same thing as pressure 2 times volume 2 after you do something to it. So pressure times volume within that closed system is always constant. Body plethysmography, in order to accomplish body plethysmography, what you do is you put a patient within a closed box. So it is a closed system. So you have your patient within this closed box. And in this closed box, you know the volume, and you are able to measure the pressure within this closed box. So in body plethysmography, you are measuring the pressure and volume within this closed box. But at the same time, so you have the box system where you measure pressure and volume. At the same time, you also have the patient connected to a pressure valve where they are breathing. And so we'll put our patient here with our airways here and our lungs down here. And this patient is connected to another valve that is able to measure pressure. So in body plethysmography, we are measuring the pressure-volume relationship within two systems, within our box and within our lungs by this second system. And so what we do is we tell the patient to breathe, and then when we notice that the patient is at the functional reserve capacity, a valve is closed. And as that valve is closed, the patient is instructed to breathe against that closed valve. And as a result of that, this lung volume will change as the patient inspires against this closed valve. So you will get a change in volume as this patient inhales against the closed valve. And what you do at this time is you measure the pressure in the box, and you measure the pressure in the valve against which the patient is breathing. So the first thing you do is you take the box system, the closed box system. And in this system, the pressure which you measured before you closed the valve, the volume in the box before you closed the valve, which you knew, is equal to the second pressure after you closed the valve, which you measured, times that first volume minus the change in volume that occurs as that patient inspires. As the patient inspires, you get a change in volume. And so using these values, you are able to calculate the change in volume that occurred. So using this closed box system, you've calculated the change in volume that occurs. Now you apply this to the closed lung system that we also measured. And in the closed lung system, you had a pressure before you closed the box times a volume, and the volume at the immediate time before you closed the box was the functional reserve capacity, and this is your unknown value, the value you're trying to calculate. And so that is equal, after you closed the valve, times the new pressure times the volume, and the new volume is the functional residual capacity plus the change in volume. So what you can do here is substitute the change in volume that you just calculated from up here, and you are able, with the substitution, to calculate the new functional residual capacity. So this is how you use body plethysmography to calculate functional residual capacity.